Lesson 50, Polynomial Equations, Ordered Pairs, and Cartesian Coordinate System. A few lessons ago, we learned about polynomial expressions. Today, we're going to talk about polynomial equations, and that is when two polynomial expressions are connected by an equal sign. Here we have three examples. In the first one, we just have x. So it's x to the fourth power minus 3x squared plus 2. In this case, the degree of the polynomial is going to be 4 because it's the degree of the highest degree term. In x, y, z plus y equals 5, that is a third degree polynomial because we have one of the terms that has a degree of 3. Finally, we have y equals 2x plus 7. In this case, the highest degree term is 1, so it's a first degree equation. Now, in an equation, we can find a value of x and y that makes that equation true, and we call that solution. Now, when we have two letters, like in this case, x and y, I can work with the value of x to find the value of y. Because we start with x is going to be our independent variable because we choose what the value of x is. And then we find the value of y. The value of y depends on x, so y is the dependent variable. It's important you remember that. So let's find the value of y. In this case, if I change the value of x for a 3, remember to use parentheses, then we get 6 plus 7, which is 13. Now, what does that mean? It means that if I were to change the value of x and y, so in the equation y equals 2x plus 7, I'm going to change the value of y for 13 because that's what we found is the value of y. And then I'm going to change the value of x for 3 because that's what it was given. This is going to be true. So let's see if this is true. So we have 13 equals 2 times 3 is 6 plus 7. And 6 plus 7 is 13. So this is true. And that's why the point 3, 13 is a solution. Now let's talk about this point. It's going to have x first and then y. And it is a pair of numbers of x and y that gives me the solution for an equation. Now, an equation like this is very important that you start getting familiar with these kind of equations. That's the equation of a line, and we will learn more of that later. But because of that, we have infinite solutions, infinite points that are going to be part of that solution set or that are going to be part of that line. Okay, so start getting familiar with that idea. So let's continue with this idea of ordered pairs and the coordinate system. You guys have learned this before, but it's good to do a little review. As we were saying before, the ordered pair is x and y. X is the independent variable, y is the dependent variable. And it's always in that order, it's always x and y. And this is a location here on the coordinate system. So I like to think about it as directions, and I'll explain why. So let's remember a little bit of the coordinate plane. As you can see here, we have the x-axis and the y-axis. The x-axis is horizontal and the y-axis is vertical. Now, in the center, we have the point 0, 0. That is the origin, that is where things start. Then from there, we're going to be moving. And so, for example, here, the first line, that is 1. Then that's 2. That's 3, 4, and 5. Notice I don't have to write all the little numbers because I know that each line, each little square represents 1. Now, don't do a line in between because that line in between is a point, but it's in the fractions. That is not a whole. So let's work only on the lines. And then on the other side, we have the -1, -2, -3, -4, and -5. Now notice how to the right is positive and to the left is negative. Then we do the same going up. Each line is going to represent a unit. So that is 1, 2, 3, 4, and 5. The same thing going down, that's -1, -2, -3, -4, and -5. So, as you can see, the points are going to be different in each quadrant. In the first quadrant, this is the first quadrant, the points are going to have both coordinates positive. So x is going to be positive and y is going to be positive. In the second quadrant, which is here, x is going to be negative and y is going to be positive. In the third coordinate, we're going to have both negatives. And in the fourth coordinate, we're going to have x positive and y negative. So let's graph these points. We have point A at -2, 3. So again, remember, we're going to start with x and then we're going to do y. So imagine you are at the origin and you have to walk -2 first on x and then 3 on y. Well, -2 is telling me to go to the left, and so we will go here 1, 2, and then 3 up, 1, 2, 3. So the point is right here. So to avoid all of these extra lines, we're going to try to do it without having to write on the thing. So let me erase it here so that it looks very nice. The next point is 0, -4. 0 is telling us not to move to the left or to the right, but only go down 4. So 1, 2, 3, 4. B is on the y-axis. You cannot do it on the outside. It has to be on the y-axis. Then we have 5, -4. So again, starting at the origin, we're going to move 5 to the right and then 4 down. So C is going to be here. And finally, D is 1, 2. So we will move 1 to the right and 2 up. And that is D. Now, if we have a point, like that red point, let's call that point E. We're going to do the same thing. We have to imagine ourselves at the origin, and we're going to move to the left 6 spaces because E is in -6. And then we have to go up 2. So the point E, the coordinate for x is -6, and the coordinate for y is +2. And that's it. That's the answer for E. Now, this is very easy. As you can see, this lesson was very easy and it's very important because you're going to be doing a lot of graphing, a lot of working with the coordinate system and order pairs. So make sure that you get very familiar with this. Okay, see you in the next lesson.